Hello friends, welcome to my YouTube channel, and today we are going to discuss about stemming in the natural language processing. This is part 2 of the natural language processing series, and if you have not watched my first video, which is the part 1 wherein we discussed about tokenization, I strongly recommend you to watch that video and then you can come to this part of the video to have better understanding. So without delaying, let's start with stemming. So in the previous video, I spoke about tokenization, which is the first step in which we split a paragraph into sentence and then sentence into word. So after doing that, the second step that comes into picture is the pre-processing, and stemming is one of the technique we use in order to do the pre-processing. So in stemming, we are basically bringing down the word into its word stem. So for example, consider that there are few words like connection, or I say connecting, or I take connected, or I take the word connects. So if I take all these four words, I understand that the root word or the stem word for all these is basically connect, right? So if I have to make my machine understand all these words without confusing it so that the redundancy or the word redundancy is avoided, I need to somehow reduce all these words to its simplest or the word stem form, which is the connect. Now, stemming is one of the technique that help us to do that. It's not 100% successful in all the conversions, but in most of the cases it works well. And where it is not successful, there are another techniques or another modifications performed on this library so that we can do it. So guys, let's jump to the coding part and understand how the stemming technique works. So basically, in this section of the video, we will understand how different stemming techniques are used in order to reduce the word to its simplest form, I would say. So basically, there are four stemmers available. The first one is the Potter stemmer. The second one is a snowball stemmer. Third one is Lancaster stemmer. And then we have one more, which is the regex p stemmer. So I have not included regex p stemmer here. The reason being, it has got something extra to add which will make our video longer. So I'll create a separate video for this and we will discuss there in a great detail. So let's jump to the first one, which is the Potter stemmer. So again, the base library is nltk, and let's import it first. And as soon as we import the first library, the first thing we need to import from nltk.stem is the Potter stemmer. Now we have to initialize it, and I have included some word which will help you understand and clarify your doubts around how this all different stemmer technique works and what is the limitation. So let's execute this and understand the first one. So in the first one, I have used various forms of word insert like inserting, insertion, inserted, inserts, and this technique is successfully has successfully reduced these to its simplest form. But now if I talk about these words like generous, generate, generously, and generation, these all were not able to be reduced by this technique, and unfortunately we got a word which is gener, which is a meaningless word. Now let's talk about the other words like eating, eats, eaten, puts, putting, and all these were successfully changed to its simplest form. So in the snowball stemmer, again I'm using the same word, and once we execute this, let's understand how this works and what benefits it has over the previous one. Now here we have to give one more parameter, which is the language, because it works on the language like Spanish or French. So we have to specifically include the language as English here because we are doing the stemming on the English words. Now when I execute this, it has successfully converted the form of insert with simplest form. Now for this generous, generate, generously, and generation, it is able to somehow reduce these two words to its simplest form, which is generous. But again, this generate and generation, it got confused, and again it changed to a form which is meaningless. But we'll see in the later part how we can overcome this scenario. And again it worked successfully on this word like eating, eats, eaten, puts, and putting. So far all good. Let's move to the Lancaster stammer now. In the Lancaster stammer, I always prefer to use this because it works with most of the word forms, but wherever there is a limitation, I use regex p stammer. But let's see with an example here. So nltk.stem contains this Lancaster stammer, and once we import it and initialize it, I'm using the same words again, and once I execute it, it works well with insert, form of insert, generate, generous, generously, generation. It got confused and it changed to the word gen, which is a meaningless word. Don't worry about these. And the rest of the words, eating, eats, eaten, puts, putting, is successfully reduced to their simplest form. Now I talk about all these in a single place. Then let's do a sort of comparison wherein I have written a short code, and if I run this, don't worry about the code. I will put it in the in my GitHub library, and I'll share the link in the description so that you can use it. But for now, if you see this, the word that I initially used are on the leftmost side, and then here it is the Potter stammer technique, snowball stammer, Lancaster stammer, and the regex p stammer. Now important thing here is this generous, generate, generously, generation. We were not able to reduce it using these three techniques. So there is a manual thing we can do for the words wherein we are not able to understand or we are not able to reduce it to the proper base format. We can use a regex p stammer expression here. So what all I have to exclude from the word, I will be giving here. And then suppose I remove this, for example, which is ing, right? And then I execute it. So you see here, inserting is not change. Why? Because I have not included inserting here. But now if I give ing dollar and then a pipe, right, and then I execute it, it has removed the ing. Similarly, we can remove ed from it or ly from it. So it's kind of a customized removal from the word post the study. So this is something a manual intervention is required. So we have to review the words, and if there is anything we want to remove manually to avoid the word redundancy, we can use this regex p stammer. But for now, if you understand that most of the cases are covered by one or the other stemming technique, and we got the base form of the word. So I hope you found this video helpful, and if you like this video, please subscribe my channel and continue to watch the series of NLP.